Lesson 14.12, definite integrals with substitution type 2. So this is now doing the use substitution completely by yourself and end up getting the area under this function from 0 to 2. And so this is kind of a lengthy process, but let's start by what we know. We're going to take the innermost function, that's 2x squared plus 1, and that's going to be our substitution for u. Then I have to have a derivative of u, so that I'm going to get in terms of dx to be able to replace that x out. That would become 4x with respect to u would be dx. Divide away the 4x to get dx solved for. So dx equals du over 4x. All right, so we're ready to make the substitution or rewrite here. Again, I'm not going to keep the same bounds, so I'll leave those alone. I've got 2x. And actually, what might be easier is taking the 2/5 out in front. I'll leave it for right now just so you can see. But I've got 2x times u to the 1/2 power, which is a square root, over 5 times, now I'm replacing dx with du over 4x. So what can simplify? Well, my x and my 2/4 is going to become 1/2. I'm going to go ahead and take that out. So that's a 1/10. Going to come out, and then I've got, this is gone, so now I've just got u to the 1/2 du. Okay, the other thing we need to go ahead and do is change our bounds. U is going to equal 2 times 2 squared plus 1 and 2 times 0 squared plus 1. That'd be 4 times 2 is 8 plus 1 is 9. And then 0 squared is 0 times 2 is 0 plus 1 is 1. So now I'm going 1 to 9. Okay, this is the step where now I'm ready to actually perform this, which means to antiderive, take the antiderivative of it. So I'll have my 1/10 times, I'll do brackets here. Remember, we're adding 1 to the power. So if I were to add a whole to a half, that's 3 halves. But then I need to divide by 3 halves or multiply by 2/3. And then I'm doing that from 1 to 9. So then I plug in my b, I plug in my 1. And the reason I can do this is because I know these are u values. So I can sub them in for u. If you weren't going to change the 0 and 2, you couldn't do this. So I have 1/10 times 2/3 of 9 to the 3 halves minus 2/3 of 1 to the 3 halves. Okay, 3 halves. Do you remember that that means the square root of 9 cubed? Well, what's the square root of 9? That's 3. What's 3 cubed? That's 27. So I'm taking 2/3 times 27, which that'll make a 1 and a 9. So that I actually get 18 here. Minus, well, square rooting 1 is 1. 1 cubed is still 1. So that's minus 2/3. And then that times a 10th. Okay, I think I'm just going to do that on a calculator. So 18 minus 2/3 and then times 1/10. Math enter. 26/15 is the area under this curve. Almost 2. All right, number 2. This one's the same setup other than now we have something that's a radical in the denominator. Again, we're going to start with our u substitution. That u is going to be the 6 minus 5x. Take the derivative of u, and that's going to be negative 5 dx. Divide by negative 5. So dx equals du over negative 5. So I never even need this again. I'm going to go ahead and change my bounds. U is going to equal 6 minus 5 times 1. And u is going to equal 6 minus 5 times negative 2. That would be 6 minus 5 is 1, and that would be 6 plus 10, which is 16. And so this kind of creates a problem of I've got big to small. You could change it when we're done, or you could leave it and it will still turn out okay. You kind of have the options here, and I'll show you that. Well, let's go ahead and write, we've got 15/4. And then I think I'm going to go ahead and rewrite this as a u, since it's on the bottom, to a negative 1/4 power, because the radical is the 4th root. So it's to the 1/4 and it's on the bottom, so it floats up and it's a negative. Replace dx with du over -5. Okay, so then I can reduce my 15/5. That would be a 3 over 1. And so if I factor that out now, or take it out, that's going to be a negative 3/4. If you wanted to, right now, you could go ahead and switch and say, I want to do this from 1 to 16, but now it's going to negate what I had in front. So I can just go ahead and make that positive. That kind of makes it easier for my brain to handle, but you wouldn't have to. Okay, so now is when I want to take the antiderivative, which is going to be add 1 to this power. So that would give me 3/4, but times 4/3 times, because I'm dividing by 3/4 or multiplying by 4/3, and then I'm doing that from 1 to 16. Love this because that's going to actually cancel. So now I'm simply doing u to the 3/4 from 1 to 16. Plug in your 16, plug in your 1, do it on a calculator, but what this means is the 4th root of 16, meaning what number times itself 4 times is 16, that's actually 2. To the 3rd power is actually 8. And then anything with a base of 1, taking 4th root of 1 is 1, 1 to the 3rd power is 1. So 8 minus 1 should give me a total area of 7.